In this video, we'll look at how to factor a quartic polynomial. So the polynomial given is quartic. It's x to the power 4 plus 3x cubed minus 38x squared plus 24x plus 64. We need to use factor theorem and try an x value that might work for that, like x equals 1. So we'll sub in x equals 1 into that polynomial. We get 1 to the power 4 plus 3 times 1 to the power 3 minus 38, 1 squared, plus 24 times 1 plus 64. You can use your calculator here if you need it. 1 to the power 4 is easy. 3 times 1 squared minus 38 times 1 squared is just minus 38 plus 24 plus 64. And I can see this is going to be way bigger positive. There's only one negative number. There's no way that's going to equal 0. I can try it on my calculator, but there's no point. So we like to pick small integers. I tried x equals 1. It could be any integers, but for us they're typically going to be small. So I'll try x equals negative 1. Try doing that, and so we'll do negative 1 to the power 4 plus 3, negative 1 cubed, minus 38, negative 1 squared, plus 24 times negative 1. This is good because I should get some more negatives, which is the problem last time. I had too many positive numbers. Here I have negative 1 to the power 4 is just 1, plus 3 times negative 1, minus 38 times 1, minus 24, plus 64. And so that gives me 1 minus 3 minus 38 minus 24 plus 64. Well, that looks close. Let's check it out. 1 minus 3 minus 38 minus 24 equals, yeah, plus 64. We got it. Equals 0. So that's good. We know that minus 1 is a factor. So we'll set up synthetic division, and we'll use the negative 1. We always use the 0. And we'll use the coefficients of the original equation, 1, 3, negative 38, 24, 64. By this point you should be familiar with synthetic division. You can watch other videos on how to divide polynomials before we learn to factor. So bring down the 1, you get a 1 here, multiply. Put it in this spot and add. Now multiply. Negative 38 plus negative 2 is negative 40. Multiply. Add 64, and multiply again, you get negative 64 and 0. So we have x plus 1, that comes from a 0 of x minus 1, times, this is my remainder, so these are my constants, my x's, my x squareds, and my x cubed. So we have 1x cubed plus 2x squared minus 40x plus 64. And now we're going to work with just this inside polynomial. We're going to try and factor it. We need another x that works, so we could try x equals 2. And let's see what happens when we do that. We get 2 cubed plus 2 times 2 squared minus 40 times 2 plus 64. By the way, we already know that here 1 couldn't have worked, but negative 1 might have worked again. We might have tried that, but I chose 2 first. Gives us 8 plus 2 squared is 4 times 2 is 8. 40 times 2 is negative 80 plus 64, and it was a good choice, as 8 plus 8 is 16 plus 64 is 80 minus 80 is 0. So we've got another factor. I'll continue up here. And we'll do synthetic division on this inside polynomial. That is, we're going to divide 1, I'm looking at this, so 1, 2, negative 40, and 64, and our 0 is going to be 2. So bring down the 1, we get 1 times 2 is 2, 2 plus 2, 4. Now multiply, you get 8. Now add, negative 32. Now multiply, negative 64, and add. Got remainder 0, which means we were right. We knew we were right, but I'm sure I did it right. So now we have, oh, and I should put f at x here. I forgot last time. Let's put f at x equals. So we have f at x equals, the first 0 we got was negative 1, so there's its factor. Then we had 2, so its factor is negative 2. And now we're left with the remainder, so constants, x's, so x squared plus 4x minus 32. Well, now we just do some work on the side, and we break down x squared plus 4x minus 32. We ask ourselves, what multiplies to negative 32 and adds to 4? You can watch a video on this of how to do quadratic factoring. This I call Bergman technique. So you can learn from that video how I'm doing this technique. I'm looking for what multiplies to negative 32, adds to 4. The numbers are going to be 8 and negative 4. So we get x plus 8 and x minus 4. So now we have, from that result there, f of x equals our original two factors and the two factors I just found using Bergman technique. And now we have fully factored a quartic polynomial down to a full factored form.